Hey guys, welcome to the final question. We're finally here of the 2026 AP Chemistry, question number 7. Let's get started. Sodium metal reacts with oxygen gas according to equation 1. Standard enthalpies of formation are provided in table 1. Part A. Based on the information given, calculate the value of delta HF for sodium oxide shown that work leads to your answer. Really? Uh, are they serious? Wait, what? Okay. Well, sorry to all right, so here we go. Look, take a look. So what does this says? This means per that, right? But what do you see here? You see that, right? So essentially what it means is that I mean this one's really it's too simple. It's just what? It's every molar reaction is actually 2 moles of sodium oxide. So there we go. So it's essentially stoichiometry, isn't it? Right? So let's solve this. 7a, right? What do we do? How do we solve it? All right, so to solve this, you got negative, what is that? 828. Is that 828? Negative 828 kilojoules per mole reaction, right? Negative 828 kilojoules per mole of the reaction. And then stoichiometry says in 1 mole of the chemical reaction in the equation, you end up with, you produce 2 moles of your sodium oxide. All right, that's it, right? Because they want it for sodium oxide. So therefore, what happens? This gives you negative 414 kilojoules per mole. So the answer would be negative 414 kilojoules per mole. And just do that. You're done. Let's go to B. A's done. An 18.4 gram sample of sodium reacts with 12.8 grams of O2 according to equation 1. Calculate the total amount of heat and kilojoules released during this process. I can't believe that this is just a simple stoichiometry problem, right? All right, well, let's solve it. Stop complaining of how easy it is, but just solve it. 7b, okay? All right, so let's go to solve this. We need our equation. So that's 4 sodiums and an oxygen yielding 2 sodium oxide. All right, so it says 18.4 gram sample of sodium. So it's 18.4 grams and 12.8 grams. All right, so what do? We actually have to calculate the moles, right? So for sodium, it's 18.4 grams. And I don't remember, it's been a year since I taught AP. So therefore, I don't know if it's 23 or 22.9988. So I'm going to go take a quick peek. And yes, 22.99. So 22.99 grams per mole is sodium, right? That gives me, let's see, calculator is 18.4 divided by 12.99 gives you, am I doing this right? 18.4 divided by 22.99 is 0.800. So, 3 sig figs, 0.800 moles of our sodium. Let's go for our oxygen for O2. O2, we have 12.8 grams of O2, and each O2 is 16 or 15.9994. It's 16. So it's going to be 32.00 grams per 1 mole. What does that come out to? That's 12.8 divided by 32. That gives me 0.400 moles of O2. So who's the limiting? Let's think about this. You need 4 times as much sodium as you need oxygen, right? So if you have zero point 0.4 moles of oxygen, 4 times that is 1.6 moles of sodium that you need. We ain't got that. So what do we know? This is our limiting, and this is our excess, right? Dude, if you can't do limiting and reagent problem, I don't know why you were taking this test, right? So I'm not going to even explain that, right? So let's go. So that's the limiting. So this is the excess. And sodium is going to dictate how much we're going to create. All right. So they want the amount of heat in kilojoules, right? So what do we know about this? Well, look, heat of the reaction is what? They have heat of the reaction is um negative 828 kilojoules, right? So what does that mean? That means this is endo or exothermic, guys, right? This is right. It's negative. It's exothermic, right? Which means that what? It's released. So you could actually write it like this as part of the whole equation, right? So if you write it like this, then what happens is that now it seems to make a little bit more sense, right? I mean, unless you're really good with it, but that's fine. So now what we're going to do is we're just going to solve the problem. Sodium is the limiting reagent. So it's going to be 0.800 moles of sodium, right? And then what do? We know that it's 4 moles of sodium per 1 mole of a chemical reaction. For one equation, that's the reaction, right? For the entire equation, you get 4. That's what this is trying to say. And then what else we know? We know that the delta H value is negative 828 kilojoules per 1 mole of the reaction, right? So, hey, we've got color. Let's use it. Hello. So we got this cancels that, this cancels that, leaves us with kilojoules, and that should be our correct answer. So let's do it. And if you punch it into the calculator, 0.8 divided by 4 times negative 828, I get negative 166 kilojoules. All right, so calculate total amount of heat. So total heat is 166 kilojoules. There you go. 7B's done. Oh boy, we're very last question. We're going to celebrate after this, right? Lattice energy can be enthalpy, sorry, lattice enthalpy can be defined as the energy required to separate an ionic crystal into gaseous ions. Rubidium oxide and sodium oxide have similar crystal structures, and their lattice energy enthalpies are given in table 2. Using Coulomb's law, explain why the lattice enthalpy of rubidium is smaller than that of sodium oxide. And man, like this Coulomb's law has been kind of weak in this test, right? I mean, they asked a lot of it, but it's been very weak. So what's the difference between these two? Rubidium is here, sodium is here. What do we know? Rubidium is larger, right? So we know that radius or rubidium is larger than radius of Na, right? So what? Hey, that's Coulomb's law, right? So since this Coulomb's law is what? F is Q1, Q2 over R squared, right? Think about that, right? Rubidium having a larger radius means it's dividing by a square of a larger number, which means that your force is going to be smaller, which means that the force between rubidium and oxygen is going to be much smaller, right? Which is right. We're done. I just explained it. All right. So let's just put it in words, wrap it up, and then finish this up, right? So that's part 7, question B. Right? Really? That's only B. Wait, no, hold on. That's C, right? Yeah, I noticed on the on question 6, I kept writing question 5, right? So I don't know if you caught that. All right, so hello. Can I please? Okay. All right, so how do we say this? Well, we can say, right? It says why the lattice energy. Okay, say rubidium has much larger radii, right? Than that of sodium. Okay. Since F is proportional to Q1, Q2 over R squared, according to Coulomb law, rubidium oxide, right, will show a smaller Coulombic force between RB and O, thus translating to a smaller lattice energy. And we are done. That's it, guys. So that's it. I thank you for staying with me if you actually saw through all the problems. Also, like I said, this is done without any answer key. So if you do find something that is wrong with it, feel free to call me out, although I think I got everything right. Um, and hey, if College Board posts their answers later, I don't know, a couple of weeks, right? And if you see something wrong, feel free to comment in the comments. Thanks for watching, and I guess see you next year.